Hi everybody. Welcome back to surveying. This video is for the spring of 2020 after our extended spring break. So this lecture actually will prepare you to begin classes again after April 6th or on April 6th, which is the day that we'll be coming back after our extended spring break due to the coronavirus pandemic. So I am recording this on Saturday, March 28th, and I'm going to post it for you today because I want you to have access to the material. I've restructured our material a little bit for extra clarity, and also wanted to talk to you about how the labs are going to work for this class. So having said that, I'm posting this about 9 days ahead of April 6th so that you'll have the information. Should you choose to work ahead, the Moodle page will be available to you, but you are under no obligation to begin your work until April 6th. So having said that, I've done a little bit of changes to both practical surveying and engineering surveying, and I'll show both of the pages to you, but let's start with engineering surveying because there are more students in here. Before spring break, I had organized the lab procedures together, and then I'd ordered the material together sort of more by topics. Now, what I'm going to be doing after spring break, I'm going to be organizing by week, and also I'm going to be pretty careful to keep the topics together and to keep the topics for engineering surveying and practical surveying as close as possible. Now, right now, so what we're going to be doing for the week of April 6th through April 10, and oddly enough, April 10 is actually Good Friday, so we don't have class that day, but, so it's actually April 6th to April 9, but I'm leaving it as such. So the topic for this week is using an instrument called a theodolite, which requires us also to talk about zenith angles and vertical angles, and then if we go to our textbooks, in this material will be due on, or what we'll be working on will be chapter 7 in the text. So this vodcast, chapter 7, is about what you'll need to do for the vertical angles and horizontal angles. There are notes beneath it which go along with the lecture, so that you can pull up the notes while you're watching the vodcast. And then we have a lab on theodolite operations. And as I've noted, this is the first virtual lab. I'm going to go over this with both groups in just a moment, but having said that, I want to show practical surveyors what their lab page, what their web page looks like, so that you'll be ready as well. Once again, I've broken stuff out so that we have the same lecture and the same notes. Now, this homework, which is actually on this material, I've extended the due date to April 10th just to keep everybody in the same line, and then we have the lab for practical surveying as well. Now, after you watch the video and you are able to take a look at the lab, what you'll see is there's some similarities and then there are also some differences. But basically, what I have done for both classes is I've asked you to watch the video on this lab, which is this one, the one that we're talking about right now, and then it tells you the specifics of having to use a theodolite, and I'm going to go over a picture with you in just a moment. But what I've done this time is I've provided you the data. So normally you would be collecting this data, you would be collecting the distance and 4 angles using a theodolite. And because of our current situation, I've provided you with that data instead. Now, the data that I'm getting is from a student of several years back who gave me his lab notebook. And so the data came from an actual lab. So it's good data. Doing a lab this way is obviously different than doing it in the field. But I think that with your background so far, in terms of setting up a tripod, setting up an instrument, leveling the instrument on the tripod, and taking readings, you have a lot of basic skills to build upon. So you'll be able to relate to what we're doing. So anyway, so this is the data that you are going to be using when you write up your lab. But basically, here's a plot of what we're doing. I have two views. I have a plan view and a side view of the science and math building. So basically, point A right here is where the theodolite would be set up in order to take angles. Now, as you'll learn, a theodolite does not take distances at all. So to get this distance from A to C, from the point where we set up the theodolite to the science and math building, you would use a steel tape at this point. And it's mathematically imperative that you get a right angle to the science and math building. So using a steel tape, you can do that using the idea that a triangle that's a 3, 4, 5 will always be a right angle. So you can measure off a distance with the steel tape that would be some factor of 3, maybe let's just say 3 meters. And that means that you need a factor of 4 coming straight back, which if this was 3 meters, this would be 4 meters. And then you would extend 5 meters on the tape here. Then you can put a loop in the tape right here, very carefully, because if you kink it, you're going to break the tape. But you can put a loop in the tape here and have one person hold the tape edge at the building, one person hold the loop, and one person coming out to the building again on that 5 leg. Now, it does not have to be on the edge of the building. This drawing is just an example. It can be anywhere on the building. But if you do the 3, 4, 5, what you'll find is you'll adjust this to where this will have to be a right angle. There are other ways to measure right angle, but with equipment in hand, that's one way to do it. So anyway, we set up the theodolite one time at point A. We take this distance A to C with the steel tape. Then we measure this angle. It's called a horizontal angle to the left because you start here at 0 and you measure to the left, and you take the angle measurement to the north edge of the building. Without moving the theodolite, you then re-zero the angle and take an angle to the right to the south edge of the building. Okay, so now you have this distance and you have 2 angles. So based on those 2 angles, you can find this distance and that distance added together. In other words, on this diagram, CB plus CD would be the width of the science and math building. Now in the plan view, we would do the exact same thing. We are not moving the theodolite once again, but we still have this distance A to C, which is the same as up here. Now we measure a vertical angle to the top of the building and a vertical angle to the bottom of the building. The vertical angle this way, when you go down, is sometimes called an angle of depression, and the angle going up is sometimes called an angle of elevation. But all of this is available to you in your textbook. So if you take a look at the sections in here on theodolite, if you need further clarification, it will be available to you here, and similarly here. All right, so given that that's the data that you have, what I then want you to do is to use the data that I've given you, which you would get from this. You'll notice it's in meters just because that was the tape that the steel tape that the student had at the time. And then I want you to write this up in your field book. When this student wrote it up, they did a really nice job of it, and that's actually why I chose to use this data. But basically, it looks something like this. Now, there are note forms in your textbooks that will tell you how to do this, and I want you to follow your own work and to submit your own work. Each of you will have to submit your lab notebook. In the past, we've done it in groups. Now, if you guys wish to work together virtually, that's super. I don't have any problem with that. Just make sure that you record who your group is and what you're doing. So, having said that, we're just going to do 4 more sections. We know the school year. Come over here to my calendar. Well, let me just finish this off right now. Underneath the lab, there's a submission button, and I'd like you to turn this in by April 10th. That will be a picture of your lab notebook with your data as though you've collected it, and then the work that we're talking about. Now, for practical surveyors, this math is a little bit more than you are required to do. So if you're not familiar with getting those actual distances, just get the data recorded and draw the diagram of what happened. Okay, so having said that, let's take a look at our calendar for the rest of the semester. Oh, here's already open, sorry about that. All right, so if we come over here and we take a look at the calendar, and we take a look at the calendar for April, you'll see that we have, let me stretch this out a little bit. If I can, it doesn't want to stretch out for me. All right, so let me see if I can minimize this and get, no, I can't. All right, so the weeks that we have left are the weeks beginning April 6th, which ends on the 10th, April 13th, which ends on the 17th, April 20th, which ends on the 24th, and May 27th, April 27th, which ends on May 1st. Okay. The next week is our finals week, and we will have a final exam. We obviously will not have an equipment final exam. It will just be a written exam during that week. But basically what that tells me is we have 4 weeks left, and we're going to have 4 topics. So the first topic, as we've been talking about, is using a theodolite. The second topic will be a total station. The third topic will be GPS, and our final topic will be the public land survey system. So as far as your course pages go, I will keep those in modules. So this week will be all of the stuff having to do with the theodolite. For the engineering surveyors, there is no additional homework. We did not submit our homework chapter 4. Which will be submitted this week, so there's no additional homework, just this lab assignment. For the practical surveyors, you've already done some stuff with theodolites, and the homework was originally due on March 3rd. I received some of those, but not all of them, so I've extended that due date to April 10th. So everybody has a lab assignment, only practical surveyors. Well, and both of you have a homework assignment, but they're actually from before. So the next week, which will be April 13th through the 17th. There will be another module that looks like this. It will say second week after spring break, April 13th through April 17th. There will be some lectures, a homework assignment, and a lab assignment on the total station. Following week, there will be a similar setup, a similar module for global positioning system, and the final week of classes we'll have a similar setup for the public land survey system. Now, this is really uncharted territory for all of us. I want you to know that I am available to you anytime that you need to talk. So I'm still working. I'm working from home, but I will have my email on all of the time. I'll answer you very quickly if you have questions. And if we need to meet face-to-face, we can either do a phone conference, or I have a web conferencing program called Zoom, which you may or may not be familiar with, but it's very easy to use. And I will be available to you via those methods until the end of the semester. So our final exam will be proctored on Zoom, because that will be the week of May 8th, ending in May 8th, I believe. But there's no indication that we're going to be able to meet face-to-face by that time. So it would be probably a good idea for you to give Zoom a try. So if you want to give it a try, if you've never done it before, just let me know, and I will get you a link, and we can practice. All right, so everybody, good luck. I know we're all going to be fine. Like I said, you don't have to do anything this week, but I'm putting this up so that you'll have it available to you should you choose to get ahead. But we'll meet back virtually on April 6th, which is a week from this coming Monday. And I'm available here for you. We'll figure it out if there's anything that doesn't make sense to you, and we'll just move forward. So have a great week, and we'll talk to you soon.